Hello and welcome to Unprofessional Engineering. My name is James.
And you got Luke.
Luke, we're taking a listener recommendation this week. Yeah, we just please the community.
I'm fairly certain that we are probably the most customer-centric podcast that has ever existed.
I agree. We certainly are.
Are they customers? Listeners. Listener-centric,
They
sorry.
certainly don't pay, so...
Cheapsters.
We're going to be talking about welding basics. And I was saying it was welding to start, and then there was just so much information that I changed it to welding basics.
Yeah, my thing was there. If you just Google welding, which is what we both did, there is just so much information. And then the history of welding was like, it was crazy how much information there was.
You know, I didn't really look into the history, so
I did a little bit, a very little bit, because there was just so much.
Okay, so a little high-level stuff. How about that?
Okay.
Traditional welding techniques would be stick welding, Mig, or metal inert gas, and tungsten inert gas, which would be Tig welding. These are the three welding types that make up probably 90% of all welding that's done.
But James, what actually is welding?
I mean, Luke, that's a great question. Please tell me what is.
Welding is a fabrication or sculptural process.
Wow. I did not see that.
That joins materials, usually metal. You can also weld plastics. We're going to focus, I think, on metals.
Isn't that? Yeah, I guess.
Yeah, it is. By using high heat to melt the parts together, allowing them to cool, causing fusion of the two different components.
Fusion.
And there is, in almost all cases, there's some where there isn't. There is typically an element that is added to that weld that actually produces the stronger weld. Like sometimes there's friction welding where they just rub these things together at such a high speed that they end up fusing together. But usually there's some type of additional material added that lays that weld bead.
Yeah.
And that actually strengthens the weld.
Yeah. Well, that's interesting. Yeah, I mean, not really. It's just the basics, right?
Yeah.
Is that interesting?
I think it's interesting.
Okay.
I mean, how else did you hold stuff? How did they hold stuff together before welding? They didn't have nuts. They didn't have nuts and bolts back in the day. They didn't have glue. They were using ropes.
Ropes, yeah. So there are also more advanced options like plasma arc and laser welding. Let's not talk about those too much.
I have them. We can
though.
mention them.
Okay. So in each of these, you're going to want to tack the pieces together just as a heads up. So that basically means you're taking little welds to hold the pieces in place, and then you can put your good weld on there.
Well, the other thing too that you need to do, and I spoke with my,
you have an expert that you talk to.
And literally an expert. So my nephew, David, he was a apprentice welder in the local union here in Pittsburgh, and he just recently became a journeyman. I think is the next step in the process, and so he's a great welder. He does a great job. So I was talking with him, and apparently probably the more important thing than those little tack welds to kind of hold thing is the fixturing. And that's a whole nother design and engineering process. Is if these things are slightly out of whack, so let's say you're trying to make a 90-degree corner and it's not exactly 90 degrees, the jig that you have that's holding those two components together is just as important as the weld itself, because once you start welding these together, these two pieces now become one piece, and having to change that after the fact. So the fixturing and the jigs that you use for welding, at least when you're in a shop welding. Obviously, if you're in the field, it's a little bit different because you're just kind of working with existing conditions. But when it's in a factory, and this is where robotic stuff comes in. I have a little bit of stuff later on robotic welding, but it's just as important. So it's not just how good a welder you are, it's is the jig good and is the fixturing good.
Wow. So I saw, and later on I'll talk about equipment a little bit, and this is more like if you're going to be doing it in your garage, like as a hobby or a small shop, that a triangle is like one of your best friends, making sure that your angles are tight.
Mm-hmm.
So well done, Luke.
Thank you.
So let's talk about stick welding first. What do you think?
Okay.
Or do you have history? Do you want to talk about that?
So yeah, and I have brief history because it literally
history.
goes,
You mean sentence?
Yeah, a sentence. So and the reason it's only a sentence is because literally this goes way back before it was even welding, where they would basically just melt different materials, pour them. It's soldering was really what they were doing. They were just melting materials. They weren't getting up to that super high temperature that you think of welding, but welding came out of that. So
I thought soldering might be an interesting episode sometime as well.
Yeah.
Just to discuss how that works and why you would use it.
But the main piece of history, so in 1881-82 time frame, inventors Nikola Bernardo, he's a Russian cat, and another guy by the name of Stanislaw Oślowski, a Polish guy, created the first electric arc welding method known as carbon arc welding using carbon electrodes.
Carbon electrodes.
Yeah.
How about that?
But that was the first like real machine that was legitimate production. They made them, they sold them, and you could actually weld stuff.
Do you think the rivet business really went under with?
I don't know, because
welding?
if you look at the way they do a lot of bridges nowadays, even nowadays, the bridges are held together usually by a combination of welding and rivets. But I would think that riveting it's a different method.
Yeah. Okay.
It has its own structural benefits versus welding. So,
well, tell me a little bit about stick welding, would you?
okay, so stick welding, also known as arc welding, and this is probably, like when I think of welding, this is what I think of. So with stick welding, you're typically going to have an electrode or a stick that
Oh, wow.
that is connected to, and again, I'm not a welder, so we're going to get a whole bunch of welders.
I know.
It
they're
looks
gonna
like you
yell.
got a jumper cable connected to it.
Yeah.
So you got a jumper cable here.
I like to think that if you bought a better setup, maybe that's not what it looks like,
It
but it kind of does.
It still looks like it.
Yeah.
So you got this stick that is the electrode, and you have it hooked up to a jumper cable. Basically, another jumper cable is connected to the workpiece that you're working with, and then basically the minute you get that electrode near those two components in the workpiece, there's an electric arc that occurs.
There is.
The material that is in the rod basically solidifies the electric the electric arc basically heats up that really small specific area to some crazy temperature. I didn't get the temperature. I don't know if you have that off the top of yours, but basically it takes those two pieces of metal where the electrode is hitting, liquefies them because it's so hot, and then as you pull the stick away, the stick melts and it lays a bead of that material, and then they create fusion by melting together.
Yeah, it's a pretty crazy process, isn't it?
Like that's like when I think of welding, that's what and the welder that I want to buy. I told you I want to buy a welder. That's the kind I'd like to get
Well, of course,
because it's the easiest or one of the easiest.
That's what they say, is that it's one of the easiest, which is cool. I saw that you could buy one for about 230 bones at the Home Depot.
Yeah.
So that's kind of cool. There's also 3 versions of them. I assume you'd be doing like an AC version.
Yeah.
So the 3 types would be AC, DC, or AC/DC, like the band, but different. So AC is the cheapest and good for metals thicker than like a 1/16 of an inch. And DC are more expensive, but give you a cleaner weld and are better for thinner metals, even though I feel like a 1/16 is pretty thin. I mean, in my mind it is. So some of the advantages of stick welding: it welds steel, stainless, cast iron, hard surfacing, and aluminum, but you got to watch out with aluminum, I think. The only electric process that can weld cast iron, suited for windy outdoor conditions. So especially if you're doing this stuff at home, maybe you don't have a garage that would block the conditions, this would be perfect for you. And it can be used for welding on dirty or rusty metals, which oftentimes we are doing. So the cleaning process isn't quite as important there. DC is good for out-of-position welding. Some disadvantages: not good for metals thinner than 1/16 of an inch, like we talked, so 16 gauge. So that makes sense, and it tends to have more splatter than the other process. So the stuff coming off, as well as the weld, isn't going to be as clean.
Gotcha.
Make sense?
Yes, it does.
So I had a little more information on here. Miller Electric, who I was stealing a lot of my information from. I mean, researching
mine was Lincoln Electric.
Oh, nice. Really?
Yeah.
That's really funny. They offer a great read on improving stick welding techniques through their clams guide. So what is clams? C, current setting. L, length of arc. A, angle of electrode. M, manipulation of the electrode, and S, speed of travel. So check out Miller Electric, go through there, and you'll learn a little bit more about how to actually position everything and use the equipment that we're talking about.
Yeah, the interesting thing the welder that I want to buy, it's actually on Amazon, and you can't find it. because it's out of stock because this guy did a review on YouTube.
Oh, and now it's like the hottest.
And
Get it? Hottest welder.
You didn't even plan that, did you? So this guy did this review. It's a $160 welder, and he's like, "This is the cheapest welder you can possibly buy." Gets it on Amazon, and he welds with this thing, and it worked. And this guy's like a professional welder. This is what he does for a living. YouTube channel is kind of like a side business. And now you can't get the welder, but apparently a big thing with these kind of, I'll say, hobbyist welders that really limits them is the duty cycle. And the duty cycle is for, and I forget if it's in hours or like that, but basically for every hour that machine is running, how much of that is it actually welding and laying a bead down? Because apparently these machines overheat and they can't run at that current level.
It's like quality control right there. That's nice.
So the cool thing was this super cheap welder, it had like a 20% duty cycle, I think is what he said. So for every hour, you could get like 20 minutes of actual weld time, which for a hobbyist and something that I might do is more than enough, I'm sure.
I would hope if you're fast.
Yeah, so it was. Well, I wouldn't be fast.
All right. Well, before we move on to the other methods, let's take a break for a word from our sponsor.
Already? Okay.
Yeah, let's take a break. Heck yeah. So this week we are being sponsored by no one
Lincoln Electric?
ourselves. No, I tried, and they said, "Shut your face, James." I thought it was rude.
Wow, that was rough.
Sorry, Lincoln. We do have some shout-outs, though. We have Abdullah M. says we have great chemistry, which is nice to hear, and we're very entertaining. Suck on that, Fallon. Saying I'm not funny. Hurt my feelings. All right. Adam from Cad Noobs wrote in again with some... So this is funny. He suggested we talk about supersonic flight, or maybe the Concorde, which is one of the topics we had already discussed doing, which is interesting.
I could see us doing that one. That's interesting.
This guy wrote in. He had a sweet name. I can't say his last name, but the whole thing was really cool. Donato G. Right down the road from us in Elizabethtown College in Lancaster, or Lancaster, depending on who's saying it, is spreading the good word in his sustainable engineering club at college. So thanks for the help. I was creeping on his LinkedIn profile a bit because that's what I do. And he's big into eliminating the carbon footprint of the world, which is something we're passionate about as well.
I am super passionate. And the fact that he's doing this with the Amish in Lancaster is great.
Well, I mean, it must be easy to reduce their footprint, right? And last but not least, Dustin H. was actually the one who suggested we do this topic. So a shout out for the idea, and hopefully we're not, embarrassing ourselves.
Dustin Hoffman?
Dustin Hoffman, I believe.
The actor.
I think so.
That's what the
He's
H
a big
stands
listener.
for?
Yeah, he's a big fan of the show.
Is Dustin Hoffman still alive?
I think so.
I
hope so. So, if any of you want to suggest some ideas or maybe score some sweet stickers, email us at unprofessionalengineering@gmail.com.
And subscribe.
Oh my goodness,
Reviews.
subscribe and write us reviews on iTunes or wherever you listen, and we will be able to retire soon.
All I want for Christmas is a review.
Oh, that would be great.
If every listener just gave us a little gift of a review, we would be the biggest thing ever.
That's great. And now I have to post this one around Christmas. Thank you, Luke.
Sorry.
All right. So moving on, we're going to talk a little bit about MIG welding. You want to give me the lowdown on that one?
So MIG welding, this is one of the easier types of welding for beginners. MIG welding is actually two different types of welding they put together. So first you use what's called a bare wire and then a second flux core. The bare wire MIG welding can
flux capacitor.
Flux capacitor. The bare wire MIG welding can be used to join thin pieces of metal together. Flux core, and there's so many acronyms here. This is where this got confusing for me. Flux core MIG welding can be used outdoors because it does not require a flow meter or a gas supply. MIG welding is usually the welding of choice for DIYers because it's actually pretty easy and the equipment isn't that expensive.
So, just as a reminder, MIG would be metal inert gas.
Yeah.
So that's the only abbreviation we'll touch on here. Bonus, though, the gas that's sent through the torch prevents oxidation of the weld.
I never understood
that's kind of a nice
that.
Bonus.
Yeah, and the sticks, apparently, so with stick welding, the sticks actually have a coating of material on the outside, because I guess what happens if you...
They look like sparklers to me.
They do. It's exactly really thick sparklers. Yeah. So I guess what the inert gas does, or the exterior, the flux that is on the outside of a stick, is if you would weld without the inert gas or without some of the flux and some of the material there, you'd end up with these super oxidized welds, and then they're not strong and they break brittle, and they have problems. So the gas actually prevents all the oxidation, gets rid of the moisture, gets rid of any contaminants that might be there. So
it's good
kind
gas.
of interesting.
Little info about that gas. So the type of shielding gas depends on the type of wire. So for mild steel wire, the gas is C25. And so for those who don't know anything, that is 75% argon and 25% CO2. For aluminum wire, the gas is argon. For stainless steel, the gas is called trimix, which is argon, CO2, and helium. I don't know how people came up with all this.
How did they discover that
this needs to be used here?
Yeah.
I guess if you know the chemistries, it probably makes sense.
People much smarter than
us. Chemistry.
Yeah, people much smarter than us, I'm sure, did a lot of this work. So
advantages for MIG: weld steel, stainless, and aluminum. Continuous wire feed makes the easiest process for learning. It produces clean welds, cleaner than other processes like stick. And it can be used for high-speed welding, provides good control, so that's kind of back to the easier process. And the disadvantages, it must not be used in windy conditions, so you have to do it indoors pretty much. Yeah, and all paint and rust needs to be removed from the material before. So we said with stick, you can have rusty, dirty, gross metal that you're slapping together. This thing has to be very clean and nicely done.
Can we talk about the continuous wire feeders for a second?
1 second.
Okay.
MIG welders start around $600 I saw at the Home Depot.
Bad.
I did see one for $320, but I don't know if that's, something I want to do.
Yeah.
So go ahead. Tell me more.
So this is kind of interesting because this is actually, if you think about welding and what's happening, especially with the continuous wire feeders, what they do is there's a giant spool of basically the welding stick is on a spool instead of a stick, and then in the handle of the welder, there's a guide that you thread the wire through, and then it basically feeds the wire through this. So if you think about that, that is the exact same thing that's happening with a 3D printer, except 3D printers are doing this with, some sort of, plastic material or whatever they're 3D printing.
Not all of them.
Well,
ceramics.
A lot of them.
Anything that we would use. Yeah.
Yeah. A lot
Like
of the consumer grade ones are using some type of plastic or PLA or whatever it happens to be. But it's literally the exact same mechanism that is driving that wire through there. And interestingly, we've seen these advances, and we'll talk about robotic welding in the future, where literally they're using welds to do 3D printing. So you have a robot, and it's basically just laying weld material on top of existing weld material. It's not actually joining.
That must look ugly.
There's a lot of prep and cleanup. We actually interviewed some folks that did that with propellers in Rotterdam.
Yes. Wow. Good job, Luke. Well done.
The guy was
really, 19 feet tall.
He was really
and
tall.
My wife and her friends were watching the interview because apparently he was much more attractive than us two.
Which was hurtful. That's pretty easy to do.
I felt it was subjective, but if anyone was going to be on my side,
you think the wives would?
Well, what can you do?
Alrighty.
So let's move on to one more topic here, and that's TIG welding.
Mm-hmm.
Could you give me a little breakdown on that one?
So TIG welding is an extremely versatile, but it's also one of the more difficult welding techniques to learn. Yeah, and I think this is because this is a two-handed technique.
Do you have a flame in each hand?
No, you don't have a flame in each hand. So one hand feeds the rod while the other hand is holding the torch. So you're actually feeding two different things at one time.
My left hand is so bad at stuff. How could I do this?
And there's a foot pedal that is actually driving the continuous feeder.
Yeah.
And I looked up
it could just be a button by your hand.
You would think they'd be better, but maybe you get some fatigue in your hand or something like that.
Yeah.
So the interesting thing about this is used on almost any kind of conventional metal. You can do this on aluminum, steel, nickel, copper, cobalt. But the thing is, the way they do this, because you have to keep this stuff continually moving. If you ever look up, just Google TIG welding, and this is the welding that you see that has that figure eight kind of pattern in it. And what it is the person doing the welding, they do this kind of cool thing with their hand to kind of keep that torch moving as they're feeding in some of the material and as they're doing the foot pedal. And you talk about coordination. I mean, like you said, I can't.
Oh yeah.
I can't catch
it's
or
impressive.
Throw or write with my left hand. Literally nothing. And they're using two hands to create these amazing welds.
Agreed. It's impressive.
Yeah.
These suckers run you about $1,000.
Yeah.
They use for the gas argon, inert gas, or other inert gas mixtures for shielding, kind of like MIG.
Mm-hmm.
Some of the advantages, you mentioned some. So AC TIG welders can weld aluminum as well as magnesium alloys. DC, on the other hand, welds brass, copper, steel, stainless, and titanium, which that seems impressive to me. It provides the highest quality and most precise welds, and you can weld the thinnest materials, is my understanding. Some disadvantages: it's more expensive, of course. It requires much more skill and experience to work with this method. So maybe your expert could do it. We probably couldn't. And it typically is a slower method as well.
So you know how they qualify these guys?
How?
And girls
You
that
said
are
some
in welding
ridiculous
school?
amount of time, right?
Yeah, so number one, again, going back to my nephew, so they actually, on the job, you do a weld, and then what they do is they have, a more senior person come in, they inspect the weld. In some cases, depending on the weld, they do like x-rays or like
It makes sense.
Not ultrasound.
To make sure your heat affected zone
yeah,
is all
to
good.
make sure you have 100% penetration of the material whenever you're doing different welds, and then basically you get certified to do different welds on different jobs, and basically the more certifications you get, the more money you make, and we'll talk about that a little bit later on. But it's a really detailed, like, I couldn't just walk in as an apprentice and start welding anywhere I wanted. You have to pass all these different certifications and be approved, and then you can do certain types of welds.
Do you like how I threw out heat affected zone like I've ever welded
You
anything?
have no idea what a heat
Right? I can model it in FEA, but otherwise.
affected zone.
So before we move on to any other information, which will be extremely valuable to our listeners, let's take a break for this week's Luke's Rant.
Yeah, so this rant is against, I hate to say liberal arts degrees. But so, and again, I'm bragging on my nephew here quite a bit this show. He is getting a lot of shout outs. Maybe he should. He makes enough money. We'll talk about that too. Not how much he makes, but but the thing is, so I've listened to a handful of Mike Rowe, the Dirty Jobs guy, and just listening to him and then seeing what's happening. And we've talked about this in the past. Thinking that you have to go to a 4-year college, even for engineering, I think is sometimes maybe a little much, depending on what you want to do. My nephew went to a trade school, has an associate's degree or certificate, went for welding, has an amazing job, works his tail off, makes a ton of overtime. I mean, here's this 24-year-old kid, zero debt, living wherever he wants to live, driving whatever he wants to drive, money pouring out of his pockets, and he has no school loans. And I just think that what students need to start considering in high school is, do you want a desk job? You got to think about that sort of stuff, and don't just think you have to go and get a 4-year degree. And I think that's slowly starting to change. And I think welding as a profession is a perfect example, because most welders nowadays are a bunch of old, crusty guys sitting in a shop, and there's this huge gap that's happening specifically with welding, this skills gap that you hear Mike Rowe talk about a lot, and it's being filled not at the same pace that these old-time welders are leaving, so tons of opportunity, and you know how it is. If you're in high demand, you can make more money. So
Absolutely.
So seriously consider kids. Seriously consider, you don't have to go to a 4-year school. You need some kind of education, vocational, whatever it might be, but think about welding, think about trade schools. Unless you are like the next, I don't know if Miley Cyrus is a good example. Unless you were like the next Pavarotti or the next
I did not know where you were going
Jack
with that.
Kerouac, do not go to school for a liberal arts degree. If you're going to make a ton of money because you're the best singer, the best actor, the best dancer, the best artist, do it. If not, liberal arts is going to be just a lot of money and a lot of time and a lot of working at Starbucks.
Probably have a lot of fun for 4 years.
Yeah, but then you come out and you get...
know, I'm just saying.
Come on, you're not helping me here.
I thought I was. All right, so moving on. Outside of hating on people going to school for
I'm not hating
liberal
on
arts, let's talk a little bit about the equipment that you're going to need
Yep.
if you're going to be doing this at home in particular. So I went through a whole list of good stuff. One, you're going to need a welding helmet.
You know why you need the welding helmet?
So you don't go blind.
Yes.
Wow. Thanks for that,
The
Luke.
brightness of the welds lead to a condition called arc eye, or flash burns, in which ultraviolet light causes inflammation of the cornea. It can burn the retinas of your eyes.
Yeah. Have you welded before?
I've looked at it intentionally / unintentionally a few times, and it's not good. You get white spots in your eyes for hours.
Yeah, so I did a little bit of welding in one of my classes at Penn State, and even with the helmet on, man, that stuff's bright.
Yeah.
So, yeah, I can only imagine. So they actually have self or auto darkening masks on some of them, so that's pretty cool. Safety glasses. Now, I would think that the welding helmet could be made out of material that would mean you don't need this, but safety first, so make sure you don't lose an eye on top of it. A particle mask. So just like if you were driving around India or China. Have you ever been to those countries?
No, I haven't.
Oh, everyone has like a mask on just because of pollution and whatnot, but it's the same like this. You don't want particles flying in there.
And there's a lot of
bad
bad stuff when you're welding.
Yeah, particle mask is great. A chipping hammer. So this is less about safety and more about the actual end product. So I'm guessing if you're really good, you probably use the chipping hammer a little bit less, but when you're getting started and when you're doing stick anyways, just because the weld isn't quite as fine, you probably need it more.
There's a top level of oxidation that occurs. A lot of that material that's in the stick gets left over and it just breaks right off.
A leather cape. This is back to safety because you don't want to catch on fire.
My nephew told me about one time. I guess he had a spark go down in his boot and like beside his sock or something like
Just,
that.
Like burnt a hole through everything. Yeah. Welding gloves. Your hands are going to heat up. I mean, no brainer there. And what's going to probably be one of your best friends, other than that triangle we talked about, is an angle grinder. So for fitting joints, removing burrs and slag, and just like grinding the weld bead
That's
in
what
general.
They sound like.
What was it again? That is what they sound like. I can back you up on that.
Okay, can I talk about the types of welds?
Oh my goodness, I want to hear all about that.
Okay, so this isn't the welding technique. This is the physical geometric conditions. These are things you and I are probably more familiar with since we're not welders. So there's 5 basic types. I'm sure there's way, way more, but there are butt joints. So this is basically where you take 2 pieces of steel, you butt them together, and you're basically just welding those 2 components together. This is typically where you need, we talked about that weld penetration. You want to make sure that it goes all the way through the thickness of the 2 materials. Lap joint, this is obviously you have 2 of them lapping. There's typically welds on both sides and all around the corners. A corner joint, this is probably the one you're thinking of most, basically 2 corners coming together. Edge joint, and then finally a T-joint. And we use, in our industry in engineering and design and manufacturing, we use all kinds of weld symbols to indicate the type of welds they are, the size of the welds, any specific preparations. Were you ever good at like annotating weld symbols and doing that sort of thing? No.
I mean, that's saying, have you ever done it? And I'm like, not really in practice.
I have, and I wasn't great at it, but it's like, it's almost one of those things where you have to know how to put things together. So it's like you have these engineers who have never welded telling welders how to put things together. And in my experience, whenever I was working in this industry, what I found was no matter what the engineers were indicating on the drawings for
you act like you weren't the engineer.
Well, it wasn't me. It was some other people too.
Okay.
The welders were just doing the right thing. They were like, no, a 1/4-inch fillet weld's not going to work there. It needs to be this. I'm just going to do
That's a lot of the rule of thumb / like just learned knowledge that goes into this.
Yeah. And my guess is what was happening was a lot of these welders were, having to go back and redo things because, I called it out incorrectly or whatever it might be. So, so that was kind of interesting. So I think that an engineer could take some good tips from a welder, perhaps.
All right. Is that all of your weld types that you wanted to cover?
Yeah, that's all I had.
Okay, so could you give me a quick breakdown on the job pay and the outlook, and then I have some welding tips for everyone that are going to get started after being inspired by us.
Nice. So, this is national average in this previous year, 2018. The average pay for a welder is $44,000 a year, and that's actually pretty good. I mean, if you think about it, that's the average. It's not the max. It's not the minimum.
Is that what an average is?
Yeah. This does not include things like overtime and all the different benefits that they're getting. But the crazy thing about this is you need very little. We talked about this in my rant. You can make $44,000 a year with, in some cases, just an apprenticeship, maybe a certificate for going to a welding school. But you can make that kind of money with very little specific education. It's really on-the-job training. The U.S. Bureau of Labor Statistics are reporting that welders are going to be expected to grow by 26% by 2020. That was some of the drop-off that's happening. You got a lot of welders that are retiring and aging, and you don't have this net new workforce because people don't do on-the-job training. So decent pay. I can tell you my nephew makes more than the average, and he's like 24 years old. He makes a lot more than the average because it's overtime. It's all the specialty stuff he's doing. And then the only other thing I want to mention is you hear all about robots. And a robot's going to take over the world. And I don't think they're going to take over. We were at Autodesk University not too long ago, and we saw that robotic welder that was inside of a shipping container. I think robots are going to still weld where they're welding now. They're going to be inside of factories doing production line type stuff, but in the field type welding, you just can't get a robot to account for kind of those existing conditions whenever you're out in the field. So I don't think robots are going to move into the traditional human welding environment as much as they'll just be better at what they do in like factory layouts and those sorts of things.
Love it. A couple tips.
Shoot.
All right. Understanding AC and DC current. So basically learning which one you should do for what job to get a strong weld. And that will just kind of save you time and money and give you a better quality product. Clean the material before starting. So scrub it well with like a wire brush or a grinder or sandpaper even to remove a lot of the dirt and rust from the material.
Scrub-a-dub-dub.
Scrub-a-dub-dub. That's the tip. Well done. Remember to put your helmet down. You'd think that's a no-brainer, but just like anything, you get kind of fatigued because you're used to doing things. Yeah. You just don't think about it. You don't put your helmet down, you're in trouble.
I just squint a lot.
Or even if you're new and you're worried about the welding process in general, you might forget to put the helmet down. Tacking, necessary step. We've covered this a couple times, but you have to put, short welds in place to hold the pieces together and then put your weld in. Have your head to the side. I thought this was a good piece of advice.
I don't get that one. Let me think.
Well, you keep it away from the smoke. So you're not like right up in there getting all the fumes and smoke in your face. So it's the best place for you to have a full view of the joint as well. You mentioned the different types of welds that we could go in there, the butt joints and lap and T-joints. A grinder, have one nearby. We mentioned this as well. And then popcorn or bacon. This is my favorite. So many people, apparently, if you're into welding, they'll tell you that when you're welding, if it sounds like popcorn popping in a microwave, it's like the settings are either too hot or too weak to get the job done properly. If you listen for that, quote, sweet sound of bacon frying in a pan, that's when you know your weld is at a good spot.
Oh.
Popcorn bad, bacon good.
I have to ask my nephew that one.
Yeah, I wonder if he'll back that up. I'm going to say he will because I wouldn't have said it otherwise.
Okay.
So do you think that you're ready to go get that welder and start some jobs?
So it's on my Christmas list.
Nice.
And now, granted, I'm not going to get a job. So all I want to do is be able to just weld a few little things for my vehicle and my basement and just some home projects, that sort of thing. If you need anything welded, James, let me know.
I might actually need something welded once you have this and you've practiced a few times on your own stuff.
Well, thanks.
All right. Not that I doubt you at all.
You do.
All right. Well, hopefully everybody else learned at least the basics of welding here, and hopefully Dustin Hoffman is not embarrassed by the job we did. If you have any questions about welding, feel free to reach out to us, and we probably won't give you a good answer, but, we'll write back
We can direct you to the right people.
That's right. So until next time.
See ya.